If your mama ain't got no soul, you ain't got no soul, you ain't got no soul. If your mama ain't got no soul, you ain't got no soul. If your daddy ain't got no soul, you ain't got no soul, you ain't got no soul. If your daddy ain't got no soul, you ain't got no soul. If your mama ain't got no soul, you ain't got no soul, you ain't got no soul. If your mama ain't got no soul, you ain't got no soul. Oh, if your mama... Oh, hi guys. Hey, you just caught me just a little bit earlier than I was expecting you. I'm just making my usual morning smoothie. You know, it's very important to get all that nutrition in the morning, you know, to keep the body going, to keep the mind active. So, yeah, we'll just get this little bit done. And what you always need as well is, I like to throw in just a little bit of physics, just to kind of, you know, keep it in the old brain. And something to sweeten it up. Lovely. So I'll just get this done, and then I just need to put on a quick load of washing, and then we'll be ready to get going with the video. Have to get those chores done, you know, before the workday starts. I wasn't expecting visitors this early. I just had to fix this dodgy door handle as well. Whew. Sorry about that, guys. Oh, I just had to get those few bits done. Okay, so welcome back to another episode of Science at Home. And what are we going to talk about today? Well, today we're going to look at a little invention that was in all of those things I just used. Any idea what it might have been? What was making all of those things work? Well, all of those had an electric motor. An electric motor is able to turn electricity into circular motion. Okay, and we kind of take that for granted, but we can make the blades spin in my blender. We can make the barrel spin inside my washing machine. And my Hoover just works by a fan turning, which has to spin. And then my drill, of course, has to spin. But why would connecting electricity to something make it spin? How does that even work? Well, what we're going to find out today, when we dig in a little bit deeper, is that, like almost always, it's got a lot to do with magnets. Magnets seem to come up an awful lot in physics, don't they? And they're pretty crazy things when you think about it. I mean, why would one little metal object be able to attract another little metal object like that? And they don't even have anywhere for batteries. How do they even work? So we've looked at magnets a fair bit in our last few episodes, but we've never really explained how they work. So see if you can have a think there. Maybe pause the video and chat to the person beside you. How do you think magnets work? Oh, sorry. Well, did you come up with any good ideas? They're pretty complicated magnets, aren't they? Well, we're really going to dig down into it, and we're going to understand how they work. But we first need to know that there's two particular types of magnets. There's a permanent magnet, yeah, and there's an electromagnet. So the permanent magnets are the type of ones we see every day, the ones you see on your fridge. You can't turn them off, you can't turn them on, they're always on. Now, what's an electromagnet, you might be thinking? Well, if you remember from the earlier episode, we said that moving a magnet near a wire makes electricity, yeah? The magnet pushes the electrons through the wire, the magnetic force. Well, the electromagnet is the reverse. What you find out in physics is that if electricity moves through a wire, yeah, it actually creates a magnetic force. So electricity just moving through a wire creates a tiny little magnetic force. Now, you won't notice it from your electrical wires because it's so small. But if you want to build an electromagnet, you do something like this. You take your wire, yeah, and you wrap it round and round and round and round, around something that's iron. Okay, so this nail is perfect. So you wrap it around loads and loads of times. And now when the electricity flows through it, yeah, from our battery, that electricity goes round and 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 back. And so that means all of the tiny little bits of magnetic force, yeah, that are being made by the wire are all added up. And if we get some sort of an iron object, we'll see that it will stick to it and it becomes a magnet. Okay, so this is now a magnet powered by electricity. But let's go back to our permanent magnets because they're the more complicated ones we want to understand first. So to understand a permanent magnet, we need to go back down to a picture of an atom. we're familiar with this diagram by now, and for this explanation we're just going to use an atom with one proton in the middle and one electron going around outside, just to make things a little bit simpler. So we know that we have electrons that go round and round and round. Yeah, they keep going round and round the center. Well, if you think about earlier when I said that electromagnets, yeah, can be made by just passing electricity through a wire. Yeah, just passing electricity through a wire can make a little bit of magnetic force. Well, if an electron just keeps going round and round and round, well, that's an electron going round and round and round. That's kind of just like electricity, isn't it? So what you're going to notice is every single atom becomes a tiny little magnet because it has this little electron going round and round and round. So it's basically a tiny little electromagnet. Okay, so you can imagine that every object, yeah, in the universe is made of atoms. Yeah? So this table, for example, any object you can think of, has millions and millions and millions of atoms. Well, if that's the case, if every single atom is a tiny little magnet, and everything is made up of millions of atoms, why isn't everything magnetic? Yeah? Why aren't I magnetic if I'm made of atoms? Why can't I attract in metal objects? What is it that makes everything not magnetic, only certain things magnetic? Well, it's got to do with the way that atoms are put together. So when atoms all come together, millions of them to make a substance, it's kind of random and messy the way they all join up. And you'll find that some atoms might point in one direction and some atoms might point in the other direction. Some atoms might point to the side, some atoms might point at an angle, some atoms might point up, some atoms might point down. And what you're going to find is all of those little magnets that are built by the tiny atoms are all pointing in different directions. And if we have enough of them, they're all going to cancel each other out. Every up will be cancelled out with a down, every left will be cancelled out with a right, and overall the object won't have any magnetic force at all. So that's what most objects are. They're made of all these tiny atoms that work as tiny little magnets, but they're all in opposite directions, so they have no magnetic force. There's only a couple of very, very specific materials in which all of the atoms are all arranged in the exact same direction, yeah? So they all add up to make one strong magnet. Okay, so now we understand how electromagnets work, and we understand how permanent magnets work. They're just loads and loads of tiny little electromagnets. But what's this got to do with making objects spin? Well, let's take a look at what an electric motor looks like so we can try and figure it out. And like we've done before, the best way to understand how something works is to take it apart and look inside. Now, I've made sure this is unplugged and I know it's safe to do so, so I can go ahead with what I'm doing. But don't do this unless you know what you're doing. So let's go take a closer look inside. Okay, we have everything disassembled here and I can see the electric motor. Let's take a closer look so you can see too. Okay, so here is the inside of our blender. So electricity comes along these wires. Now it's all disconnected, so I know it's safe. And it's connected up to this whole thing here. All right, so this is our motor, our electric motor. Now, what we can see is when this electric motor spins, yeah, it's going to cause the center to spin here, which of course causes our blades to spin. If we can make this spin, the blades will spin. But how can electricity make this spin? And what even is this anyway, this part that I'm spinning? You might see some little coils of copper wire here, yeah? And some metal plates here and some metal plates, and some little segments of metal plates here as well. Well, if you remember the electromagnet from earlier, yeah, each one of these little sections here is an individual electromagnet. If we turn an electrical signal to these, they become a magnet. If we turn off the electrical signal, they stop being a magnet. So an electrical signal is sent here and goes to one of these little metal objects. See these little metal objects? They're all separated. Each one is connected to an individual electromagnet. Yeah, each one is connected to an individual one. So when we turn on the electricity, let's say for example, if at the moment it's connected to this electromagnet, the second we turn on the electricity, that electromagnet is going to get attracted, boom, to this big magnet that's at the side. Now this is a permanent magnet. But by the time it moves, it's already connected up the next electromagnet, which is going to get attracted again. And now it connects to the next electromagnet and attracts it down, connects to the next electromagnet and keeps going so on and so on. So you can see that every time it moves, it connects to a new electromagnet. And that keeps the motion going again and 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 again. So let's remove the blades and let's have a quick look at it in motion. Okay, so today we learned a few new things. We learned about magnets, we learned about electromagnets, and we learned that magnets are really just loads and loads and loads of tiny little electromagnets inside atoms. We also know that if you combine magnets and electromagnets in a particular way, we can make circular motion. And that's how our electric motors work. They're so useful. You just connect one electromagnet to the next and the next and the next, and it keeps going round. They're used all over the place. So hopefully you got some new insight there, guys. You got a little look inside, you see how these actually work. And once again, guys, you have to be super careful with electrical equipment. This can really do you a lot of harm. So don't do this unless you're with an adult who knows what they're doing. Take care, guys, and I'm looking forward to seeing you on the next one. Like almost always, it's got a lot to do with magnets.